In this video, you're going to kick off your section on asynchronous programming by making your very first request for third-party data. So we're going to figure out how we can get some information into our application that doesn't come from the code itself and doesn't come from the user. In this case, the information we're going to be getting is a random phrase we can use for the hangman puzzle, as opposed to the static text that's currently defined in app.js. Now, to actually set up a communication between our browser and this other server, what we need to do is issue an HTTP request. Up above, HTTP, something you've most likely heard of plenty of times before, which stands for Hypertext Transfer Protocol. The Hypertext Transfer Protocol is a request response protocol, meaning that we, the developer in the browser, we issue some sort of request. This goes off to some sort of third-party server. That server does some work and it gives us back a response. So request response. Right here, we have our request. Down below, we have our response. So up above, the request describes what we, the person making the request, hope to do. So what do we want to do? And the response contains information about what was actually done. So think about the request that we're trying to make to generate a random word or phrase for each new Hangman game. The request itself is what we want to do. What do we want to do? We want to generate a new word or phrase, and the response is going to contain that word or phrase, what was actually done. Behind the scenes, the service that we're going to use is going to generate a random word or phrase from a list, and then it's going to send that back so we can add it into the game. So this is the process that we're going to use here, and the HTTP protocol is actually something that our application is already using. These requests, though, are just being initiated behind the scenes. For example, whenever you visit a page by typing something in the URL and hitting enter, that initiates an HTTP request. Whenever we load in a script with the script tag, that also initiates an HTTP request, and we can view these inside of the browser. To view your requests, you have to go over to the Network tab. Now, the Network tab for you might be empty at the moment. Sometimes you need to refresh the page if you opened the developer tools after the page was loaded. Right here, though, we're seeing there's 4 things showing up. You might have a few more, depending on what sort of browser extensions you have installed. The first one is for the page we actually requested. Right here, we are getting the HTML document back, and we can see that. We have a document of the type HTML. If we click that, we can actually view some details about both the request and the response. What I'm interested in for the moment on the right-hand side is just what's under the response tab. What's under here? We have our HTML document. This is the document defined in index.html. Now you'll notice that what we're seeing here is a bit different from what we actually have. That is because Live Server has appended a script in here in order to set up that communication, allowing us to automatically refresh the browser whenever we change some code. But up at the very top, we can indeed see things that we actually set up. So that is the first request. Down below that, we have 2 requests for our 2 JavaScript files. The first one, hangman.js, and the second one, app.js. If we actually click one of these and go to the response for that, we see the document. Here I'm seeing the comments I just typed out, and down below that we have all of the code that makes up the file. So all of these are actually received by the browser via HTTP requests. Now the last one is a WebSocket request. WebSockets allow us to communicate between 2 things in real time, and this is used to allow the browser to automatically refresh whenever we change some data over here. So we haven't set up this last request and we're never going to be touching it or working with it. It is just coming up because we've used Live Server as our little development server. Now, all of this is great and all. It's nice to know we're already using HTTP requests behind the scenes, but how does this really help us? What we want to do is initiate a request from our JavaScript, and we want to do something with the response in the JavaScript too. Because in the end of the day, when I get that random word back, I want to actually pass it to new Hangman, so I can start a game with the randomly generated word. To get this done, what we're not going to do is make HTTP requests that send things back like HTML or JavaScript files. Instead, what we're going to do is make HTTP requests that allow us to get JSON back. we can then parse that JSON into a JavaScript object to extract the data off of it. In the case of the URL that we're about to explore, the JSON that comes back contains the randomly generated word. Let's go ahead and actually pull this URL up right here in the browser. I want to head over to puzzle.mead.io/puzzle. This is an endpoint that I've set up, allowing us to generate a random word or a phrase. And if we actually visit this URL, what's going to come back isn't going to be a JavaScript file or an HTML page. What comes back is going to be some JSON data. Now, when Firefox gets JSON data back, it knows that it's not what we actually want to view, so it sets up a little interface, allowing us to more easily explore the information. Let's see what I'm talking about by hitting enter. What do we get? We get this little page right here. We can see the JSON information, we have our key value pairs, and we could also search if we had a lot of different attributes on the JSON. But if we head over to raw data, this shows us exactly what actually came back. It is just this information, which we can see as some JSON. And if we can get this information back in our JavaScript file, we can actually use json.parse to get a JavaScript object. Then we can access its puzzle property to get basic movements, which is one of the randomly generated phrases. If I hit refresh, everything stays exactly the same, except now the phrase is underwater ridge. If I hit refresh again, we get perfect stocking stuffers. So what we want to do is figure out how we can make this request, not by typing something in the browser, but by running some code from JavaScript. That is going to allow us to set up the request, requesting a new random puzzle, and then inside of the response, we're going to be able to get that puzzle and create a new game. To do this, we're going to be adding some code into the mix, and for the moment, we're not going to integrate it with the Hangman application. We're just going to add it down below so we can explore the syntax for getting this done. Then we'll integrate it with the Hangman application to actually start a new game. I'll leave a little comment right here, making an HTTP request, and we're going to go through this process. Now, the first thing we have to do is initialize a request using a constructor function provided to us by the browser. So I'm going to make a const, and we can call it whatever we like. I'm going to call it request. This is the request that we're going to set up and configure to actually go off to that URL and get the information. And we're going to set it equal to, we'll be using the new operator with the constructor function, XML HTTP request. And pay close attention to the capitalization there. XML is all capitalized, HTTP is not. Then we're going to set up the arguments list, and this constructor function happens to take no arguments, so we'll pass none in. Now, if you've been around the web for a while, then you've seen XML before. XML was very popular back in the day, and it is much less popular these days. XML was just a different way to structure data that you wanted to transfer. So in this case, we're transferring JSON information. We store JSON information in local storage. It is a great way to represent some object as a string. XML did the exact same thing, it just had a different syntax for getting that done. It looked a bit more like HTML than it did like a JavaScript object. It was popular, it no longer is. The name here is not relevant. We can use this constructor function to transfer any information we want, not just XML. The next thing we do down below is we actually use a few methods on request to set things up. For example, at no point have we specified the URL where the JSON lives. So we have to provide this inside of our code somewhere. And this happens via the request.open method. Open starts to initialize our request, and this is where we configure two important pieces of information. The first is the URL, we already know that, and the second is the HTTP method. HTTP supports various methods. When you type a URL in the browser, this creates a GET request, so it uses the GET HTTP method. If we go over to the Hangman application, we can actually view this. Right here, under method, we have GET for every single one. This is the most common HTTP method for getting information, and it is the exact one that we're going to be setting up over here. So we call request.open, passing in those two arguments. The first is the method that is uppercase get, and the second is the URL we want to make the request to. http://puzzle.mead.io/puzzle. Excellent. And that is all we have to do for open. And the last method that we use is send. So that is request.send. We send off the request, and this is going to actually initiate the process. Now, the process doesn't take place right away. It takes a bit of time for you to connect with that server. It takes time for the server to actually do what it's supposed to do, in this case, generate a random phrase, and it takes time for the server to get its response back to you. Now, we can see this over inside of the network tab as well. We can see there's a timeline, and the timeline is in milliseconds. It all happens very quickly, and it shows you exactly when requests are started, when they're made, and how long they actually take to get done. So this is going to be very important for us. Right now, yes, we are making the request, and we are getting a response back, but we're not doing anything with it. We need to add an event listener that's going to fire when we actually have the information. Let's go ahead and save the file in its current state and see what changes over in the browser. Over in the browser, we have our 4 requests from before, and we also have a brand new one down below. This new request is to puzzle. We made it with the get method, and if we click this one and go under response, we can see that right here, we are indeed getting our new puzzle. And this one, the string was colorful ink. So the only thing we have left to do is to add an event listener. That event listener is where we can access the information, and we'll be able to do something meaningful with it, like print it to the screen in this case, and in a little bit, we'll actually be passing it to new hangman to start the game. We're going to be adding a new event listener onto request, so that is request.add event listener. And the event that we're going to be listening for is called ready state change. And you'll notice that none of these letters are capitalized. It is all lowercase. Now, what are we going to do? We are going to set up our function. So right here, we can set up a function. And like all of our event listeners, we are going to get access to an argument for the event, which we call E. And now it is up to us to actually do something when this event fires. Now, it's at this point where I want to pull up the documentation for everything that we're talking about. Over in the browser, we can find all of this documentation. I'm going to switch up our current doc tab, Googling MDN, XML, HTTP request. And we're looking for that first result, the one on the Mozilla Developer Network. And in here, we have everything we've explored so far. They talk about the constructor function in the sidebar. Down below, under methods, we have the methods that we explored. We used open to set up the URL and the HTTP method. We used send to actually send the request off to the server. What we're going to be talking about now, though, is ready state. So ready state is a property, and when it changes, our event handler fires. If we actually head over to the documentation for ready state, we can see there are 5 states with values from 0 to 4. So at 0, we have an unsent request where open hasn't been called. At 1, open has been called. At 2, we've actually used send. At 3, we're starting the process of getting the response back. And at 4, we're actually done. When it comes to figuring out what state we're in, we use these values. And the only thing that we're ever going to check for is 4. The only time we actually want to do something is when we have the information back in its complete and final form. I've never used any of these other status codes to check things in all of my programming years. So inside of this function, we're actually going to have this fire 5 different times, 1 time for each ready state change. We go between the various stages getting to the last one. If we only want to do something when 4 happens, we just add an if condition right in here. Super simple. If, in this case, we're going to be looking at e.target. E.target contains the request itself, and the thing we're going to be using is ready state, what we just explored right here. So that is dot ready state. Right here, we are going to check if it equals the number 4. If it does, we're going to go ahead and actually do something knowing we have the final response. And for the moment, all we're going to do is use console.log to print it, e.target. So let's go ahead and actually test this code out and see what happens when we run it. I'm going to save app.js. Over in the browser, I can see things did refresh, and if I switch over to the console, we do indeed have one thing printing. We have our XML HTTP request with all of its various properties. Now, a lot of these are properties that we're never going to end up using, but down below, if we look through things, we can see there are some properties that contain some interesting information. The one I really want to focus on is response text. Response text, as we can see, contains our JSON response. This is what we're going to use to actually extract the new puzzle to print. In this case, we need to parse it as JSON, so we have to use the JSON.parse method we explored earlier in the course. Right here, let's go ahead and do just that. I am going to create a new variable inside of the if statement, const data. I'm going to set data equal to whatever comes back from calling JSON.parse. And I'm going to call JSON.parse with the JSON, that is e.target.response text. Awesome. Now, instead of printing out e.target, let's print out data itself. So right here, data. I'm going to save app.js. The browser is going to refresh. And what do we get? Right here, we are getting an object back, a regular old JavaScript object. We have a puzzle property, and the value is island dance music. If I refresh the page again, we get a new one. I have skinny jeans. If we refresh one more time, I get beautiful weather. So using this little bit of code, our application is going to be able to pull information from some other server, a server that lives out there in the world. This could be a server that we've created using a backend language like Python, Java, or Node, or it could be a server that someone else has set up. For example, companies like Google, Facebook, and Twitter all have JSON APIs that you can access to pull information into your program. And that's where I'd like to stop for this one. We covered quite a bit of ground in this video exploring how we can initialize HTTP requests from our JavaScript code. This is a super useful thing to be able to do, but it also can be a bit complex. Don't worry, we're not done talking about this yet. I have a lot more to say about the code we've seen here, and we're going to add more code into the mix. For example, right now we assume that things are always going to go well, that we're always going to get a response from the server with a new puzzle. There are definitely situations where that might not be the case, so we'll figure out how to set up a bit of error handling too. All of that is coming up in the next videos and continuing on throughout this section, so let's go ahead and jump right into the next one and dive a bit deeper into what's going on.